plus 18. Now, I told you last time that all you really care about is whether or not this is a positive number or a negative number, because that'll tell you whether or not your point is above or below the x-axis. So if I do 36 plus 12, that's 48. If I take away 24, that should be 24, but it's a positive number. I know that. And the bottom, well, that's a positive number, whatever it is. So a positive divided by a positive should be positive. And so that means that when we're at -6, when we plug -6 into the function, we should get a positive number. So over here at -6, I'm just going to put a dot up above. And I said last time, it doesn't matter how far you put it, okay? Don't worry about that. Just put it above the x-axis. And now we have to do that for each of the remaining 4 points we have to plug in, right? Now, I'm not going to do it because it'll just take us too long, but I will tell you what you would get. And it is going to alternate in this case. You're going to get a negative if you plug in -2. If you plug in 2, you're going to get a positive. If you plug in 5, you're going to get a negative. And if you plug in 7, you're going to get a positive. Now on the test, please check each one, because I told you last time, it doesn't always just switch positive, negative, it doesn't always do that. So check it yourself. So -2, you're going to get a negative. +2, I put a dot above. 5, I put a dot below, and 7, a dot above. Any questions? All right.
Could you scroll down back to the math part? Sorry.
I'm sorry?
Could you scroll down back to the math part?
Yeah. Yep.
Okay, thank you.
Yep. Right there. Okay, so here's the part that this is the part that's hard to teach, because it's kind of like you see it or you don't see it. The whole idea is we have to connect the dots, okay? But we've got things that we have to do. Like the information we have up here is going to force us to draw this graph in one way and one way only. There will be little discrepancies between each of your graphs, but they should all have fundamentally the same thing happening. So I like to start at the leftmost point, and I start first by drawing it out to the left. So as I go to the left, I see that I have that magnet over there, and the magnet is going to just pull me down towards it. So that's what the left side's going to do. Now, as I draw to the right, I realize that I've got a couple of points that I've got to go through, right? I've got to go through that x-intercept. I've got to get down to that point. And there's nothing in my way. There's no barriers, nothing. So I'm just going to connect the dots like I'm back in kindergarten. Connect, connect. And then as I keep trying to draw, now is the first time I'm confronted with a barrier, right? My barrier is the y-axis. That is going to force my function to either go up. So I'm either going to turn up like this, or I'm going to turn down. And I told you last class, it's not like you get to choose. It's not like, oh, okay, well, I'll just do it the way I want to do it. It has to be one way and only one way. And the reason we cannot go up is because if you go up, you create that x-intercept, which you are not supposed to have there. So you'd be changing what we said is supposed to happen here. So you cannot go up, which means you have to go down. So just turn your graph down and just dive it down like that, and you're done. You're done with that left side. Then you have to actually like pick up your pencil and go to the next point that we have, which is this point here. And for that point, we have to draw it out to the left and to the right. So can someone tell me what's going to happen as I draw that out to the left? Well, let's start with the left. As I go to the left, what has to happen?
It needs to go up.
Needs to go up, right? Because the barrier's there again. I can't go through the barrier. I can't go down because then I create an x-intercept. And then if I draw it on the right-hand side, exactly the same thing happens. I have to turn up because I can't go down. Can't create x-intercepts. So in between those two vertical barriers, I've got this little U shape. I pick up my pencil, I go to the next point that I have, which is this one. And I have to draw to the left and then to the right. So to the left, I'm confronted with the barrier again. I have to go down Again, I can't turn up because there will be an X-intercept that I'm not supposed to have. To the right, I'm back in kindergarten, right? Connecting dots, having fun. Can't wait for recess. And then as I keep going to the right, I flatten out towards the magnet. There it is. And that's it, we're done. Let me show you a slight variation of a way a student could have drawn this that would still be correct. Let's say that when the student did these test points, right? Let's say that they said, okay, 6, you're positive, so they put a dot here. And then when they did 2, they said negative, and they decided to put it here. And when they put in, sorry, when they put in -2, they got a negative number. When they put in +2, let's say they put it here, just slightly above. And then let's say over here at 5, they decided to put it way down here. And then at 7, let's say they put it right there, okay? Let's just say that's what some other student did. Then here's what theirs is gonna look like. To the left, they've gotta go up to the magnet. They still have to go through that X-intercept, but then they have to dive down here. And then as they go draw to the right, they still have to continue to dive because they can't turn back up. In the middle piece, they still have to force themselves to go up on both sides. This dot, they have to dive down. Now, I didn't extend my vertical far enough there, but they have to dive down. They do still have to get up here and cross through. And then they have to go to this. And then they have to flatten out. So the red and the purple graphs there would both be perfectly scored 100, 100% correct. All right. So don't be afraid about those position of those test points when you plug them in. Don't be worried about that. Just make sure you follow, I guess, the rules of where the function has to go. All right, that was fun. All right, it is 10:15. We've finished 2 problems. 10:13. All right, so what now? Should we do a parabola? It's a different set of steps, so we should probably do one of those, right? Let's do the second one. The second one's uglier than the first one. Let's do the second one. How are y'all feeling about this? Y'all anxious? Are you feeling confident?
I think
feel
with the
okay.
reference sheet, it will be better.
With the reference sheet?
Yeah.
Yeah, I hope so. I mean, all right, so here we go. Quadratics. Boy, I don't even remember where the steps for quadratics are. Oh yeah, that was us trying to bomb a castle. Remember that? How to sketch a parabola. Here we go. How to sketch a quadratic function. Determine if it opens up or down. Find the vertex. Quick sketch. X-intercepts if we have any. Y-intercept. Sketch. Why don't I just grab all this? I'll just bring this over. Get rid of that. All right, here we go. So we have to know it's a parabola. How do I know it's a parabola? How do I know
Because
it's
it starts
parabola?
with an x squared.
Yeah, because the highest power of x we have is 2, okay? I have seen students before treat this as a polynomial and do the whole like left-right behavior and then do the whole crossing touching thing. That is not going to be considered to be correct on the test. For a quadratic, there's a lot of things we can figure out about a quadratic. So I want you to demonstrate that you know we're looking at a quadratic, which we are here. So step 1, up or down. So does this open up or down?
Opens up.
Up, why?
Because it's positive and not negative.
What is positive? What are you referring to?
The first number in the front.
That's right. The leading coefficient is 4, right? And since it's 4, 4 is greater than 0. So it's going to open up. So it's going to look like a U, right? And that means it's going to have a lowest point, right? It'll have a lowest point, and then the sides will open up. Okay, we know that so far. Second thing, we need to know the vertex. The vertex is actually that point right there. That point, the lowest point, that is the vertex. So the way we get the vertex is by using a formula that I gave you. And I told you this comes from calculus, and we use it here in algebra. So we have to figure out the h and the k. So h is going to be negative b divided by 2a. And for us, let's see, a is 4, b is negative 3, and c, let's just say, is negative 11. Let's just keep in mind that we know what a, b, and c are here. So negative, what's negative b? Don't mess up this part. What's negative b?
Negative 4.
Positive
3.
positive 3. So what we're really doing is we're taking negative of negative 3, right? Because b is negative 3. So we're taking the negative of negative 3. That's going to give us positive 3 over 2 times a, and a is 4. So this becomes 3 over 8. Now, unfortunately, that's a fraction, right? It's not a nice number. So you're going to want to get on your calculator at this point and turn that into a decimal. And when you do that, you'll get 0.375. Okay, that's your h. Now, to get k, we have to take that h that we just found, 0.375, and plug it into the function. That's what this formula is saying. Figure out what h is, and then to figure out k, you plug that h into the function. So that means I need to take this 4, replace all the x's with 0.375. And we have to get on our calculator and do this. So 0.375, I'm going to square it first. So this gives me 4 times 0.140625 minus, let me go ahead and do that, 3 times 0.375. No, 3 times 0.375. So I get 1.125 and then minus 11. I still need to multiply these together. So 4 times 0.140625 will give me 0.5625 minus 1.125 minus 11. So now I'm just going to do all that on my calculator. Should get negative 11.5625. All right, so at the end of the day, here's what we've got. We have a point. The x coordinate is 0.375 and the y coordinate is negative 11.5625. And this represents the point that is the lowest point on the graph. Any questions?
Yes, I got negative 10.625.
Did you make that one negative? Was that a minus?
No, I did it straight on the calculator.
Okay, so I would have to see how you typed it in. It's hard for me to tell you. What kind of calculator are you using? Do you know?
TI 30XS multi-view.
Yeah. So yeah, it's really difficult for me to be able to tell you, but I can show you what it should look like. Hold on. I'm trying to find a way to do this. Where's that thing? Give me a moment. Where is it?
I see where I messed up.
You got it? You sure?
Yeah, I forgot to square the first 0.375.
You forgot to square it. Okay. Gotcha. All right, let me get everything back here. Okay, so I can continue Chris. Step 3 is to determine, this is going to be a quick sketch. So the quick sketch is just going to tell us how many x-intercepts we have. So what I do is I draw a quick little sketch. I try and take this point and figure out where it is. So 0.375 is a positive number. That means I go to the right a little bit, and then negative 11.56 makes me go down. So I've got a vertex somewhere around here, and I know that my graph opens up. So I know that I have 2 x-intercepts, right? I have 2 x-intercepts. I don't know what they are, but we have 2 of them for sure. So that would take me to step 4, which is to find the x-intercepts if we have any. Well, we do have them. We know we do. So to find the x-intercepts, this is where we set the function equal to 0. So we need to set the parabola 4x squared minus 3x minus 11 equal to 0. Now you can either try and factor this, or you can use a quadratic formula. And in this particular problem, factoring will not work. You have to use the quadratic formula. And the quadratic formula is here. Let me set the quadratic formula up. We're going to get our answers. X is equal to, let's see, negative b, which is 3, plus or minus the square root of b squared, which is going to be 9, minus 4 times a, which is 4, times c, which is negative 11, all divided by 2 times 4. Now I'm trusting that you are somewhat comfortable with this quadratic formula at this point. Let's see, what is that going to be? 160, 176, I think. All right, so I'm going to need to add those together and take the square root, right? So we got 3 plus or minus, let me add them first. This can be 185 over 8. Now I'm going to take the square root of 185 on my calculator. I get about 13.6. So 3 plus or minus 13.6, all divided by 8. And then here's where I do my 2 different cases, plus and minus. If I do the plus, I'm not going to show the work. I'm just 2.075. I'll just say that's about 2.1. And if I do the other one, I get 1.325, negative 1.325. So those are my 2 x-intercepts. That's step 4. Any questions there? Step 5, find the y-intercept. To do that, all you do is plug 0 into the function. So that means for step 5, I'm going to squeeze step 5 in right here. I just plug 0 into the function. So that's 4 times 0 squared minus 3 times 0 minus 11. But everything goes away except for the minus 11. So negative 11 is the y-intercept. And we're ready for step 6, which is to draw this. So the way I draw this is kind of what I hope you'll do. You know, you look at everything first. You're like, okay, my x-intercepts are at 2 and negative 1, right? So as far as left and right, I need to make sure I can fit that onto my graph. So I'm just going to say like this is 1 and this is 2. This is negative 1 and this is negative 2. And then as far as up and down, the lowest point I go to is negative 11. I'm sorry, negative 11.5. That's my vertex. So I'm going to maybe count by like, I don't know, 5s here, 5, negative 10, negative 15. You don't have to be perfect with your graph. The thing I'm going to be looking for is whether or not you label everything correctly. So let's start off with the vertex. 0.375 is a little bit less than half, like 0.5. It's not quite 0.5. 0.5 is half. So I'm going to be, I don't know, somewhere around here, right there. Now that's not a point. I still need to go down 11.56. So I'm going to go down 11.56 right there. I'm going to just slap it there and I'm going to label it 0.375 negative 11 point, I'll just say 6 about. So there's my vertex. Now my x-intercepts are at 2.075, about 2.1. That's a little bit past 2. There's my first x-intercept. My second x-intercept is negative 1.3. So somewhere, I don't know, again, right around there. I may as well label this. This is 2.1. This one is about negative 1.3. And last thing is my y-intercept, which is negative 11, which is right about there. That's negative 11. And now I draw my parabola. I also mentioned to you this idea of this like axis of symmetry where you have this imaginary line and your graph should be like perfect reflection of itself over that. So I'm going to draw a U, right? It's not a V, it's a U. Go like that. And then it's going to try and do kind of the same thing on the other side. I have to say that's not bad. We're done with that problem. So on the test, I'm looking for the steps, okay? I'm looking for all this. I've had students in the past that when they get to that, I'll go back to that page. They get to that and I ask them to sketch and they do this. They just like, this is all they do. Like that. That's what they give me. And I know what that is. What that is the students just going to their calculator and they're putting 4x. They probably have a graphing calculator. Oh, shoot. Clear. I messed up. 4x squared minus 3x minus 11. So this is for those of you who, you know, did something like this in high school. Yeah, I've actually had students do that too. They'll draw that. They'll go. That's what they'll give me as their answer, which is basically like that picture, you know. So I don't care about the fact that we could go to a calculator and graph these things. That's not what this is about. This is about you following a set of steps and a procedure. And this all goes back to the beginning of this class. You know, what are we doing this for? This is a terminal class for all of you, right? You're not going to go take more math classes. This is just about, you know, following logical steps and executing a procedure. That's what you're doing with little pieces of math built in, right? There's, you know, computations you have to do and squaring and multiplication, division, all that. But it's more the bigger picture. Can you follow a procedure? All right. We have 15 minutes. Why don't I show you an example of a problem that I did not include on that review, which would be more like one of these. Okay. So I gave you a formula. Where is it? There it is. I'll copy this and bring it over. Talking about objects that fall on Earth, right? And that all objects fall on Earth at the same rate, regardless of their weight. And so because of that, we have a quadratic function that actually models that. So here it is. So I would put this on my formula sheet if I were you, right? d of t equals negative 16t squared plus v naught t plus d naught. And we talked about what all these different things mean, what they represent in the problem. So let me give you an example of how you would see a problem that would require you to use this formula. Let's say an arrow is shot upward with a speed of 300 feet per second. I guess we'll just let's put this person that shot the arrow, let's just say that they were standing on a little platform. The person was standing on a 4-foot platform. I don't want them to be on the ground because I want us to have to account for a height that they shot it from, okay? I want us to have that in the formula. Person was standing on a 4-foot platform. So here are the questions. First question, what is the maximum height of the arrow? When does the arrow reach its max height? And then last, when does the arrow hit the ground? You know, part of the reason that I chose math as my, I guess, path in my academic life wasn't necessarily because I enjoyed math. I actually struggled quite a bit with math in grade school and even into middle school and high school. It was because I couldn't stand the other option, which was, have y'all ever heard that rule, I before E except after C? Have y'all heard that rule before in the English language, I before E except after C? What about the word height? Is that I before E except after C? It's not, right? So why isn't that? Well, look, how many of you have heard that rule? Let's take a poll. How many of you have heard that rule, I before E except after C? Quite a few have not, but enough of you have. So like over half of you have heard that rule, I before E except after C. Well, to me, like if that's a rule, then that should always be the rule, right? But there's all these exceptions. It's like, unless the word sounds like, you know, it's like, and to me, my brain doesn't do well with something like that. It's like telling me that you have to stop at all stop signs, except some stop signs, you don't have to stop at those stop signs. You know, it's just like, wait a minute, then why are we calling it a rule? So that drove me crazy as a student. So math to me was a little more pure, a little more like, here are the rules, let's follow them. Why the hell am I talking about that? Sorry. I'm talking about it because I wrote the word height. Sorry. Okay, here we go. So first thing we need to do is come up with the function. Oh, and you know what? I should have put that in the instructions. Sorry. Let's change part A to find the quadratic function which gives the height as a function of time. Okay, we have a new part A, sorry. So what we need to do is we need to take this right here and start filling in the pieces we know. So d of t will equal, the negative 16t squared will never change. That will always be negative 16t squared unless you decide to be doing this on a different planet, all right? So as long as you're on Earth, this is gonna be true. Now, plus v naught, this is important. What is v naught? V naught is the starting velocity. Was the arrow given some sort of speed? Yes, right? It was shot upward. Okay, it was shot up at a speed of 300 feet per second. If it's up, that's what it says here. If it's up, which it is, then we're going to put plus 300. Plus 300, and then there's a t next to that. And then we have plus d naught, which is your height of the object. I'm sorry, I skipped it. I went too far there. Is the height of the object when it started. So because it was shot from a 4-foot platform, I'm going to say it's 4 feet. Of course, the person's standing on it also, but let's just say 4 feet. So I'm going to put 4. There. That is our quadratic. That's our function. Any questions? That answers part A. So what we can imagine is that this is a parabola. Like if we were to graph it, can somebody tell me what the y-intercept is? Just by looking at this, what's the y-intercept of this parabola?
4.
4,
'Cause it's
right?
just
It's
that-
always that number right there. So we know if we go up 4, here's where the arrow started. This parabola opens down, so we know it goes up and then it comes back down like that. So for parts B and C, it says, what is the maximum height of the arrow? And then when does the arrow reach its maximum height? They're talking about the vertex, right? Now, we have to remember that this x-axis is time and the y-axis is height. So when we're looking at this point HK, H is the time and K is the actual height. So what is part B asking for? What is the maximum height here? What is it actually asking us to calculate?
Okay.
K. And what is C asking us to calculate?
H.
H. Now, when we know that when we do a vertex, you have to do H first before you can get K. So you can't do part B until you do part C, which is a little tricky in this problem, isn't it? You have to do the part C before you can do the B. So, okay, that's that. Now, what about the last question? When does it hit the ground?
The
That's
X.
the x-intercept, right? That's that. So we want to find the x-intercepts. So how do we find the x-intercepts? We set the function equal to 0. And for that, you're going to need to use your quadratic formula. I'm not going to do this problem. I think I've given you everything you need to do it. You should go through the exercise yourself of figuring out what H is, figuring out what K is. Would you like to know? I can at least just tell you, yes? I can do it real easy. No, I better do it this way. Sorry. All right, so 0. What is going on with this thing? For some reason, my graph is not showing up here. There's something going on wrong. Okay, the answer to part D. Okay, the answer to part D, let me erase this. Should be 18.76. And I'm going to do something here. Well, that arrow goes pretty high. Really high. $14.10. So this is going to be 1410.25 feet. That's how high it gets. And 9.375 seconds. There it is. So if you just want the answers, that's what you should get. All right, are there any questions? I was able to get through at least one of each type of problem that you're going to see. I mean, the test can't be more than 4 questions. I mean, there's just not enough time, right? So make sure you come in, you're ready to go, because as soon as I give you the test, you need to get started on it, right? Because time will probably be an issue. You're sitting there taking your time and, you know, unsure about what to do, then you may run out of time. So, all right, I have nothing else. So I think we're good, right? Have a good weekend, Halloween weekend. Be careful, be safe, have fun, whatever you do, if you're doing anything.
Alrighty, thank you, sir.
All right, have a great day.
Bye, sir. Have a good day.